don't know, there's more than one frequency.
There could be chances, but it's not much. That is a
But
problem.
how would you compare then, or does it even matter if it has more than one frequency?
I did not get your question. Can you repeat the question?
Basically, let me see. Say if a data point has more than one frequency,
Mm-hmm.
then I don't know how to put it.
You can give me an example, and that is the best way to explain anything.
Okay, then let me get back to you on that.
Okay, so but let me reiterate what I was saying. Maybe that will help you.
Okay.
So in most of the times in continuous data, most of the times the data doesn't get repeated. The same data point, let's say, let's take age of some person, one of the persons here. Let's say one of the person is 60 kgs here. Okay, so 60 kgs, does it mean that he is exactly 60 kgs? May not be, right? Maybe he is 60.25 kgs. Now the question is, how many more people will be in this exact 60.25 kgs and not something like 60.21 kgs? Okay, I don't want this kind of a value. I want exact value like 60.25. So considering, let's say here there are only 4 or 5 people, considering let's say we have 50 people here, even then there is a lesser chance of getting the exact value that we are expecting. And now if I want to do a frequency distribution, I'll not get proper value out of it because every data point is unique here. But the question is, do we want uniqueness? So do we want to really worry about 60.25, or in general I just wanted to worry about 56 to or 55 to 65? In general, I never want to compare the exact values in reality. I don't know why it is not erasing it off. So in general, I do not want the exact value. All I want is some rough value. So that's why I am more interested in a range, maybe 60 to 65 or something, than the exact value, because the exact value, I mean, that's what people talk in, right? People talk about the ranges for this kind of data. Hello, Zahir, I think you're not on mute. I'm getting some echoes. Okay, so what I mean by all these things is, I do not care about the exact value, but I mostly care about the ranges. Zahir, please be on mute. Hello.
It seems like he's asking some questions.
Okay. Is he asking question? Zahir, are you asking some question? He's gone. Okay. Probably some problem there. Okay. So what I mean to say is, you do not want to exactly worry about the ranges. The exact value. All I need to see is, can I do something over some ranges? Can I bucketize things into different ranges, and in those ranges can I see some value out of it? Is that clear, or did I make sense?
Yeah.
Okay. So with this, I'm closing the descriptive statistics. If you have any questions, you can anyway ask me in any of the classes in future. Is that fine?
Yeah.
Yeah.
Yes, Sandeep.
I'm not sure why this is not going off. Okay, let me close. Just give me a second. I'm facing some problem here. Okay. Okay then. So the next topic I'll be teaching is the probability. So actually, we started with descriptive statistics, and in that we have central tendency and dispersion, and finally the shape of the data, which is kurtosis and skewness. So we are actually done with the descriptive statistics. Now, to enter into inferential statistics, we need some probability basics. Without any probability basics, it will be kind of difficult. But many people tend to get scared about probability, but it's not very difficult. It's kind of very easier than what you think. So I'll try to make sure that it is very easy. If you have any confusions, anytime you can ask me. Okay. Probability. So for understanding probability, actually the entire probability is based on the set theory. Set theory is the basis for the entire probability. So I'll describe a little bit about sets. By the way, are everyone comfortable with a little bit of mathematics? Because that's what we are going to do now.
Yes.
Yes, sir.
Okay.
Yes, Sandeep.
Okay, cool. So we are going to definitely discuss some mathematics. It's not, without mathematics, we cannot complete this course. But we will see as minimum as possible. But wherever it is required, I am going to teach it. So sets. So what is a set? So roughly we can define set as a collection of elements. So collection of what elements? So the question is, I'm saying collection of elements, but what kind of elements? Mostly of same nature. So for example, if you want to have a collection of all the numbers in the world, you can say a equal to 1, 2, 3, all the integers, when I say natural numbers, so on. This is how you can say. But the collection of elements is a kind of a it's not it's kind of a vague, it will give you only a vague idea of about what it contains inside. So there are two different kinds of sets. One which is having finite number of elements. So for example, if I have another set of all the even numbers within 10, let's say. So even numbers within 10 are finite. So you have only 4 numbers. But in this case, in the above case, this A is a set of all the natural numbers, and I do not have any number. I cannot say how many numbers are there in this world. There are infinitely many numbers. So this kind of set is let me talk about this one. This kind of set is called finite sets, and this is not finite set. When I say finite set, the number of elements in each set is, if the number of elements is not finite, then you say it is not a finite set, otherwise it is a finite set. Is that clear?
How about universal sets only?
So universal set depends on what you define your universe on. I'll describe that later, but
Sure.
just remind me if I forget.
Okay.
Okay, it's your responsibility to remind me if I
Sure.
forget. Okay.
So
But-
we don't call this A set as universal set.
It depends on how you define the universe. That's what I said.
Okay. All right.
I'll go to that.
Okay.
Okay. So then union, or let me call it as set operations. So on set, you can do some operations. By the way, let me modify this definition a little. A collection of unique elements. So in set, if there is any duplicate element, you'll use only, when you don't have a set like this set should be rewritten as 1. Always you should have a unique set of elements. And that's what set means. Now, there are a few operations that you can do with the sets. So one is union. Sorry. So union is represented using this kind of a U. And let's say there is a set of numbers where A is 135 and B is 468. Now what will happen to union? Union is nothing but the combination of all the elements in both the sets. And again, if there is any duplicate, use only one of the element. Don't use the duplicates. So what will happen to this A union B?
1, 3, 4, 5, 6, 8.
1, 3, 4, 5, 6, 8. Is that right?
Yeah, it's something.
Okay. So that's how you add up all the elements and keep it in a new set, and that is called union. And there is another operation, intersection. And this is denoted using this kind of inverted U. So similarly, if you take both the elements, A and B, here A intersection B is, the intersection means that is there any common set of elements. In this case, I don't see any common elements. Now, how do I represent this A intersection B? It is just an empty set. I can also write it as 5. This is a special kind of set where there is no elements in the set. Let's take another example. Let's say C equal to 183. It doesn't matter how the order is looking like, but as long as there are common elements, we should remove them. We should take them out into a intersection. Now let's say if I do A intersection C, what are the common set of elements? A and C has 1 as a common element, and 8 is not common. then 3 is a common element. So any set of common elements, you pull it out and put it in your intersection set. So in both the cases, if you see union and intersection, so union of two sets is another set. Intersection of two sets is again another set. Remember this very carefully. So once you do a union of two sets, you'll be getting, even if it is a one element, let's say D equal to only one. What happens with the A intersection D? It is only one element. It doesn't matter how many elements you are having in your final set. Either it is 0 in this case, or it is 1 or 2. The final result of intersection will be your another set. Remember this very, very carefully. Either it is union or intersection, you will definitely get another set. Now what happens with this phi? Phi, what is this phi? This phi is called null set, and it has some beautiful properties. So it is nothing but it is an empty set. Now what happens with an empty set? So any set A, if you do a union with phi, it will become it will become A, which means the set will come out again. You do any set union phi, you'll get A again, that same set. And if you do any set, if you take any set and do an intersection with phi, what will happen? It will become phi, because there are no common elements between empty set and any set, any other set. Always it will be phi. Is it clear?
Yes, Sunil.
Vijay, are you clear till so far? And Subbu?
So basically the final result of an intersection or a union is that it'll become another set.
Yes.
Okay.
It should become, these are set operations. When you do any set operation, you should get another set. As simple as it.
And I guess with regards to the null set, would A union, and that's called 5?
5. It's not 5. Or let me, null set. This is called phi. PHI.
Okay, fine. So now would this be another set as well, like A and 5? Because that's the...
Phi is another set.
Oh no, in the null set where we did A union phi equals A. So would that A be another set too in this case too?
A is any set. You can take any set. Assume that A equal to 1, 2, 3. Okay. In this case, when you do union with an empty set, what is union? Union is collection of all the elements in both the sets, right?
Yeah.
Now, if you take all these elements and some empty set which doesn't have any elements, you'll get all these elements.
Okay.
Similarly, if you take all these elements and do an intersection with empty elements, which means you have to get common set of elements out of these two, right? Common set of elements between some 1, 2, 3 and some empty elements, I mean, which doesn't have any elements, then there is nothing common. It means that empty set is a intersection.
Okay.
Hope this clears.
Yep. Thank you.
Okay, there is another set operation that we missed out, and it is subtraction. Now, what is subtraction? Let's say you have a set A where A is having 1, 2, 3 and B is having 3, 4 and 5, or let's say 2, 3, 5. 2, 3, 5. Now, when you do a set difference, the set difference is similar to your numeric subtraction, and the symbol is again minus. So you take both the elements, 1, 2, 3, both the sets, 2, 3, and 5. You take the common elements and remove it from the first set. So in this case, the common set of elements are 2 and 3 because those are present in both the sets. You take those common elements and remove it from the first set. In this case, the first set is this. What will happen? It will become 1. Is this clear till now?
Yes, Sumit.
Okay. So that's what is subtraction. Again, if you do a subtraction, again you'll get another set. Subtraction of 2 sets is another set. What happens if it is both the sets are same, a minus a? What happens? In this case, let's say 1, 2, 3 minus 1, 2, 3. So if you take both, if you take the same set out of the same set, a minus a kind of thing, then the common set of elements are all the elements, and you have to remove all the elements from the first set. Which one? Which is this one. So what happens? You'll get an empty set, which is nothing but 5.
In the A minus B, what happened to the 5?
What is it?
In A minus B, so 2 and 3 are crossed out because they're common in both the sets, but there's still 1 and there's 5 in the other set.
No. Like I said, you remove the common elements from the first set. If you remove only the common elements from the first set, I'll get 1. I'm not caring about the second set anymore once I get the common elements.
Okay, so basically, okay, we take the common elements only out of the first set, and then what is remaining in the first set is the answer.
Yes, exactly. So for example, let me do another, let's say C equal to only 1. And if you want to do C minus A, here C is 1, 2, sorry, 1, and A is 1, 2, 3. What do? You take out the common elements from the first set, which is 1. And once you take out the common elements, whatever you're going to write is about the first set only. So it will become 5, right?
Yeah.
I'm not caring about 2 and 3 here. I don't care. Once I get the common elements, I don't care about the remaining elements in the second set. That's how set difference is done. Is that clear, Vijay?
Yes.
Okay. So any other questions on whatever I covered till now? Okay. Let me continue. Cardinality. Now what is cardinality? Cardinality is nothing but number of elements in a set. Okay, it's very simple. You just count the number of elements in the set, and based on that you declare the cardinality. And cardinality, can be only done for finite sets, right? For infinite sets like this, I cannot say if A is a set of all the numbers in the world, all the natural numbers in the world, can I talk about its cardinality? I cannot talk because I don't know how many elements are there. There are too many elements. I cannot even count. It's infinite. So cardinality works only for finite sets. we can find cardinality only for finite sets. So let's say A equal to, let's say you can use anything, apples, oranges, grapes. So it doesn't matter what is inside the set. The set can have numerics or anything else. In this case, I am just talking about set of fruits that are present in a marketplace. Whatever I can see in a marketplace. So I can only see, let's say, apples, oranges, and grapes. So all of them I am putting in a set. Now, what is cardinality? Cardinality actually is denoted by n of something. So in this case, n of A, which is the cardinality of A, number of elements in the A. So how to find out? Just count the number of elements in the set and put it there. So cardinality of A is nothing but 3 in this case. Only 3 elements. Is that clear? For example, if there is a set of all outcomes of a die, let's say I'm calling it as D. What are the set of outcomes of D? Outcomes of dice. I can only get 1, 2, 3, 4, 5, 6. A die cannot give you any other outcome other than this. Now, what is n of D? It is going to be 6. Is that clear, Vijay?
Yes.
And Subbu and Abid and Zahir, others.
Yeah, so
Yes, Sandeep.
Cool. Yeah. So cardinality is kind of very simple. You just count the number of elements in the set and then give that number as the cardinality of that. Okay, and it is only possible for finite sets. Infinite sets I cannot say. Don't say infinity, but it's more like a cardinality cannot be found. Now that is about the set theory and everything. Maybe let me set theory. This is all you need for the set theory, mostly. If you need anything, I'll come back and add here, but mostly you don't need anything. So any questions on the set theory? Whatever I covered, it's very simple. Set is nothing but a collection of unique elements. Do not use, do not repeat the elements basically. So there are 3 set operations primarily. One is union, intersection, and subtraction. In union, just add up all the elements in the final set. So let's say, for example, if the elements are like this, instead of 4, 6, 8, let's say I call it out as 3, 6, 8. What will be the union? It will be 1, 3, 5, 6, 8. Do not repeat this 3 second time in union. Okay, I'm going to write that. Never repeat elements in any set. 1, 3, 5, 6, 8. Why you should not repeat the elements? Your cardinality will change, right? If you repeat versus if you don't repeat. In this case, the cardinality is 5. If you repeat this 3, your cardinality of the A union B will get changed. It will become 6 instead of getting 5. And that will affect your probability actually. Is that clear till now? And intersection is nothing but a common set of elements. Sometimes you may have common elements, sometimes you may not. So whenever you do not have any common elements, keep it as 5. When you have a common set of elements, put that in a set and give that as your intersection outcome. Okay, for example, in this C and D, there is only one as the common set of elements. So that's what I am outputting in the A intersection D. And sometimes you'll get null sets, especially in intersection when there is no common set of elements, you keep it as a null set. So there are some properties for null set also. Null set, if it is anything union null set, is the same set. Anything intersection null set is going to be null set again. And then we talked about subtraction. So when you are doing a set difference or subtraction, this is called set difference actually. Set difference. When you are doing set difference, take out the common elements from the first set. Do not care about the second set after you get the common set of elements. So in this case, for example, 2 and 3 are the common set of elements. Just remove them from the set. And which set you should take out? The first set you should take out. Do not care about the 5, the element 5 in this case. So same way, if you take out the same element A minus A kind of thing, if you are doing that kind of an operation, then the result is 5 because you're removing the common elements is all the elements. If you are removing all the elements, then it will become empty set. And I gave another example where 1 minus 1, 2, 3. The common set of elements is 1. If you remove that element, you will still get 5. It doesn't always mean that A minus A you should do to get a 5. As long as you are removing all the elements in the first set, keep a 5. Then we talked about cardinality, which is only possible only for finite sets. So when you're doing any cardinality for any set, first check that it is a finite set or infinite set. If it is a finite set, then just count the number of elements in the set. For example, I can convert this specific example into some generic example. If I say all the fruits in the world, I don't know how many fruits are there in this world. In that case, I cannot talk about its cardinality. So cardinality can come into picture only when I can count. If I cannot count, do not talk about cardinality. Is that fine?
Yes, Sumit. How about cardinality formulas for A union B and A intersection B?
It's the same, right? So what I said about union, intersection, and set difference. For example, all these set operations, I said that these will become another set, right? When you do a union of A union B, I
Yes,
can
sir.
call this as some K, where K is another set.
Yes.
Now I can do a n of K, right?
Yes.
It's nothing but 1, 2, 3, 4, 5. As simple as that.
Okay.
So that's what I can do. I mean, if I want to do a cardinality can be done on any set. Now, your union is giving another set. If union is giving another set, then what's the pain in finding the cardinality? It's very easy, right?
Yes, exactly.
But let me give you one more formula. Thanks for reminding.
N of A union B equal to N of A plus
No,
N.
I'll give that. Wait. I'll give that. I know that. So let me give examples for this cardinality, more examples. So what happens to when A equal to 1, 3, 5? Let me write it cleanly. 1, 3, and 5, and B equal to 3, 6, 8. what is n of a here? Or let me add one more element. I don't want the equal number of elements. 3689. What is n of a here?
3.
No, wait. I think you know this. Let me ask Vijaya then. Vijaya, can you open up your mic?
Yeah, is 3.
Of B?
4.
4. Okay, let's do some exercises here. I'm pulling up you because I was realizing that you're not having that much of mathematic background. Maybe I'm wrong, I don't know. What is A union B?
It is 1, 3, 5, 6, 8, 9.
Okay, how many elements are there? N of A union B?
6.
6, right?
Yeah.
Now, actually, N of A union B is not equal to just N of A plus N of B, right? In this case,
Yeah.
if I just add these two elements, these two cardinalities, it's not exactly equal to the cardinality of the union. Now, how do I give a formula for this kind of a, equation? So why is it not equal? The reason is I'm having some duplicate elements, right? And in union, I cannot have duplicate elements in my union. That's why I'm having lesser number of elements in the final union. Otherwise, it could have been solved. Now, how do I give a formula so that I can relate A union B with N of A, N of B, all these things. So all I have to find out is the common set of elements, right? Now, what is the common set of elements in this case? A intersection B. If I have N of A intersection B, then I can find, add that up to here, right? So that these two will equate. So can I do like this? What is N of A intersection B?
Is it 1 and 5?
It is A intersection B, the common set of elements.
Oh yeah, just wait. Just 3.
Just 3, right?
Yeah.
Now, what is N of A intersection B?
1.
It is 1. Now, the A union B is 6, but if I add up N of A and N of B, it is 7. So if I write this kind of formula, is it correct? So what I'm doing, I'm separately calculating how many elements are there in the first set and then second set, and removing the common elements. Those will become the number of elements when you do a union. And that's how I'm doing, right? Union. When I'm doing union, I'm removing the repetitions and then calculating the union. So this is an equation on cardinality that you might be using in your probability sessions. Is it clear?
Yes, Sandeep.
Yes, Sandeep.
Okay, Vijay, are you clear?
Yes.
Okay, cool. So what we'll do is I think this is a better time to have a break. We'll have a break and come back at 7:20. 7 minutes of break. Is that fine?
Yes, Sandeep.
Okay, we'll come back at 7:20 my clock.
Sure.
Is everyone back?
Yes, Sandeep.
Yes, Sandeep.
Subbu and Zahir, are you back?
Yes, Sandeep.
Okay. Okay, let me. So with this, I'm closing the set theory itself, but there is much more to talk on the probability aspects. Okay. So let me add probability. By the way, all these notes it will be available to you. If in case you're not able to access, let me know. Okay. You'll be already getting the link by now. So we'll go into probability and see how probability is related with this set theory and all. So again, as usual with all my definitions, so I'll give a very simple definition about probability. It's nothing but likelihood of achieving something. Again, it's very vague, the definition itself, but probability is more about how much is the likelihood of doing something. So for example, if I say what is the likelihood of getting a head in a coin which has only two sides, so the likelihood of getting a head is 50% chance. There is a 50% chance that you'll get a head, and there is a 50% chance that you're getting a tail. So that is the likelihood I'm talking about, but we'll get into more examples and understand how this likelihood can be calculated. So that is about the probability. Don't worry, we'll get more examples in this case. Experiment. So what is an experiment? In this case, I'm not defining the experiment itself, but anything that whose outcome is probability is an experiment actually, at least in probability theory. So for example, throwing a dice is an experiment. I can also say weather prediction is also another experiment. So all your prediction capabilities is also an experiment, right? So for example, tomorrow if I say the likelihood that you're going to have let's say one of the disease, let's say chikungunya, I think that is a way it should be pronounced. So the likelihood of you getting chikungunya is probably 30%. So any prediction, so let's say the likelihood of predicting the weather today, the likelihood of getting a rain today is 30%. So in many websites you might have already seen 30% chance of rain. You might have seen this kind of a prediction. So all predictions come into probability, and that is the reason why we are learning probability, because data science is all about predicting things. And when you are predicting, you cannot just say that there is a chance of rain today. That's not correct actually. You should always include your probability number with your prediction. Only then it is really the predictive capability is correct. Is that fine? As long as you're not including your probability percentage or something, your prediction is not valid. or not, or it's not enough actually. Is that fine? Just an intuition about why probability is needed in this course.
Yes, Sandeep.
Yes, Sandeep.
Okay. Now there is something called sample space also, which you need to learn. So the sample space is set of all the outcomes of an experiment. So what are all the possible outcomes if you keep it in a set? That is called sample space. So for example, what is the sample space for an experiment of throwing a dice? So I'm throwing a die. What is the sample space of all the event? I mean, what is the sample space of the experiment? So the die can produce 1, 2, 3, 4, 5, 6. If you keep all of the, only these possibilities are there and there is no other possibility apart from this. If that is the set of all the possibilities, then keep that in a set and mention that as a sample space for your experiment. Similarly, what is the sample space for prediction? Weather prediction? Can anyone tell? So I already gave an example, chance of rain. Any other samples? I mean, any other outcomes you'll get?
Sunny.
Yeah, sunny.
No.
Snow.
And as you mentioned, rain.
Yeah. I think that's enough. Maybe mostly we'll get this 3. Or maybe mist or something. Maybe something like that.
Yeah, cloudy.
Sandeep, wouldn't this be an infinite set?
It depends on how you define this. So in most of the cases, the weather prediction will be only few of the options, right?
Yeah, the reporting options are few, but the prediction part is not few.
That's what. So if you are only predicting sunny, snow, rain, mist, and cloudy, you'll not go beyond this mostly in your predictions. When you're predicting only these 4 or 5, then these are the only set that are considered by the weather prediction authority or the guy who is predicting.
Okay.
So yeah, there could be chances that this could be an infinite set, but in this case, all these weather prediction people who are doing this, they don't consider this as a infinite set. Otherwise, they cannot compute the probabilities. I'll tell you why. In a short while.
All right.
Okay. I think now you got the sample space at least. Then the other question is event space. And in event space, first you need to understand what is an event. Event is just a thing of your interest. Whatever you're interested in, that's what you're expecting to come, right? For example, let's say today there is a baseball match. You're not interested in rain, you're not interested in snow, Probably you're okay with cloudy and mist. Probably these two are fine. And this is more desirable actually. So out of these 5 elements in the set, when there is a baseball match or any football match or any match, any outdoor match, you're mostly interested in these 3 rather than the other 2. The snow and rain, generally you don't prefer. You prefer the other 3, right? So in this case, the event is sunny or mist or cloudy. And if you put all of these in a set, then that is called your event space E. In this case, your event set consists of sunny, mist, and cloudy. Maybe I should call it as misty or something, I don't know, but that's fine. So I'm interested in sunny, mist, and cloudy, and this is your event space. Is that clear? Okay.
Yes, Sumit.
So once you define, and you can see all of these are sets, either it is a sample space or event space, all these are sets. And to define the probability is defined like this. Probability is nothing but n of E by n of S. What is n of E? Cardinality of E by cardinality of sample space, which means number of elements in the sample space by number of elements in the number of elements in the event space by number of elements in the sample space. That's what is your probability. And actually to find out the probability, you just have to count the sets. So in this case, Zahir, when the n of S is infinite, if there are infinite set of possibilities, this cardinality is meaningless, right?
Yeah, becomes 0.
Actually, it is meaningless. I mean,
Yeah.
you cannot define this cardinality of sample space when the sample space is infinite.
Yeah.
So in those cases, this is meaningless. So it is difficult to calculate probability.
Yeah, that's
There
true.
are other ways to calculate, not just this way. But at least using this formula, you cannot calculate the probability.
Yeah.
So that is the reason why you should always try to find out the finite sets, finite samples.
Yeah, makes sense.
Okay, now so for example, let's take an example of rolling a die. Now in this case, let's say your event is let's say getting an even number. Now in rolling die, what is the size of the sample? I mean the cardinality of the sample space? 6. Now what is your event space? Let's write the event space. Event space is getting an even number, right? So generally from die you can get only 1, 2, 3, 4, 5, 6, and out of that the even number is 2, 4, 6. Is there any other possibility other than these 3? I guess no.
No, Sumit.
No. Other than 2, 3, 4, 2, 4, 6, nothing else is possible. Now what is the cardinality of event set? 3. Only 3 elements in the event set. Now the probability of getting an even number when a die is thrown is equal to n of e by n of s. What is n of e? 3. And n of s is 6. So you have 0.5 as your probability. Generally, probability is in, so what is the range of probabilities you are expected? Anything between 0 and 1. Other than 0 and 1, we should not get any other probability number, otherwise you're doing something wrong. Okay, I'm keeping it as R so that you should remember this. So probability should always be between 0 and 1. Now, what does it mean? It is a proportion. If you multiply with 100, you'll get the probability in percentage. So there is a 50% chance of getting an even number when a die is thrown. This is the interpretation. How do I get the 50%? This 0.5 into 100. When I multiply the probability with 100, I'll get the probability in percentages, which is kind of easier to interpret for many people. So that's why I'll try to use percentages format. Is that fine? Any questions still now? How to calculate the probability and all?
So
Okay. Zahir and Vijay, are you also clear?
Yeah, I'm following.
Yeah, okay, Sandeep.
Okay, cool. This should be.
Yeah, you have to be between 0 and 1.
Yeah. If I'm not between 0 and 1, then the probability is wrong.
Yeah.
It's one of the check you can do. Now, in the same example, probability, the throwing a die, what is the probability of having a 1?
1 by 6.
1 by 6. Why is that?
One
N of, 1 second. N of S is always 6 when the die is thrown, but only the event space will change. For any problem, the sample space, once it is fixed, it is fixed. For that problem, let's say if it is a die problem or it is a cards problem or anything, the sample space for each of these set of problems will be same. So in all the die problems, generally if it is only one die that is thrown, the sample space is fixed and it is 6, because it is only 1, 2, 3, 4, 5, 6, only these possibilities. Now the event space depends on the problem. In this problem, I am asking probability of getting a 1, which means my sample space will be, instead of saying, my sample space will be having only 1 in the set. Earlier in the same die problem, I have my sample space as 2, 4, 6, which is the set of all the even numbers. So mostly, for all the die problems and only one die is there, the sample space is 6. When there are 2 dice, the sample space is 36. So these kind of things you can, just remember. But once you have the sample space, event space is specific to the problem, you have to calculate the event space always, most of the times. So in this case, probability of getting 1, event space is having only one element, which is 1. Now n of e is 1 because there is only one element. So the probability is n of e by n of s, which is 1 by 6. What happens to probability of 2? Same case. The event space will have now 2. So still there is only one element, 1 by 6. Probability of getting 3, 1 by 6. I'm removing this so that I can teach some other concept. Again, probability of getting a 4 is again 1 by 6. Probability of 5, 1 by 6. Probability of getting a 6, is again 1 by 6. So that's how you calculate the probabilities for each of these. Now if you see probability of 1 plus probability of 2 plus probability of 3, P of 4, P of 5 and P of 6. If you add up all of these 1 by 6 plus 1 by 6 plus 1 by 6 plus all of these, then you will get a 1. Okay, so now there is a special name when for these kind of things, when you add up all these probabilities, when something is becoming 1, it's called collectively exhaustive. Collectively exhaustive. So the definition for this is sum of all probabilities of all events, instead of saying of events. Sum of all probabilities of events from a given sample space, or from this from the same sample space. There is a reason why the same sample space is there. Okay, and it is very important. So for example, anyway, the above is example, the probability of 1, probability of 2, probability of 3 until probability of 6 for throwing a die is collectively exhaustive. I can say that. Similarly, what is probability of getting an even number in a die? Again, n of e by n of s. What is the even space for probability of getting an even number in a die?
3.
3, because we can get only 2, 4 and 6. Out of 2, 4 and 6, what is the cardinality? 3. And n of s, for throwing a single die, it is 6 different possibilities, so it is 6. 3 by 6, or it can be called as 1 by 2. Now what is the probability of getting a, in fact it's always not desirable to use 1 by 2. It's better to use 3 by 6, because that way you can retrace the source, how it is coming. So better don't simplify this. Now what is the probability of getting an odd? N of odd by n of sample. Now what is n of odd?
3.
Probability of getting odd is 1, 3 and 5. So which is 3 different elements by 6. Now I can say that when you throw a die, probability of getting an even and probability of getting odd are collectively exhaustive. Are collectively exhaustive. I can say that even and odd are collectively exhaustive. Now I can also give another example, which is actually another counter example. It's not a proper example. Again, probability of getting an even in a die. What is it? 3 by 6. probability of getting a head in a coin, it is 1 by 2, because there are two possibilities. Sample space in a coin, there are only two possibilities. Either it is a head or is a tail. So sample space, the denominator is always 2. And probability of getting a head, there is only one possibility of getting a head. So it is 1 by 2. Now, can I say probability of getting an even in a die and probability of getting a head in a coin, are they collectively exhaustive?
No, Sandeep.
Why?
These two are entirely separate events.
Separate events. These are also separate events, right? Getting an even number and odd number. Are they separate events or same event?
Yeah, they are same event, but you are talking in the
It is
context of.
because it's in the same, because it is not in the same sample space.
Exactly. Yeah, that is right. They are not in the same sample space, so do not consider these two are as collectively exhaustive. That is wrong. This is in a different sample space where it is in a die. This is for dice, and this is in a separate sample space which is for coin. For coin, what is the sample space? Head, tail. And for die, what is the sample space? 1, 2, 3, 4, 5, 6. These two are in different domains. They're completely different. Do not consider just the probability and then say that these are collectively exhaustive. No, that is wrong. And that is a exact thing what people go wrong, where people go wrong actually. Okay, do not do this mistake. When something is collectively exhaustive, just check for the sample space. Are they in the same sample space or different sample space? These two are completely different sample spaces. Just because these two add up to 1 by 3 by 6 is nothing but 1 by 2, and this is another 1 by 2. So just because these two add up to 1 doesn't mean that these two are in the same, these two are collectively exhaustive. So that is the reason why this is added from the same sample space. Is that clear, everyone?
So basically, sum of all probabilities of events from the same sample space equal 1 is collective exhaustive?
Yes. Yeah. That is right. Okay. Any questions still now?
No, Sandeep.
No, I'm good, Sandeep.
Okay. Cool. So the probability part currently, for now, I'm parking it. Tomorrow will continue. But in the next 10 minutes, I just wanted you to download some of these softwares, and I'll try to walk you through the how to install it. So I would expect you to install it by tomorrow, so that in the tomorrow's class we can try something else. Okay, we are going into some software aspects as well. Is that okay? Because anyway, in 10 minutes I cannot do anything.
Yes, Sandeep.
Okay, so I already mentioned that in this course we'll be going through the Python code. We'll be writing some code in Python. So for you to do something on Python, you need to install something called Anaconda distribution. Okay, please Google search Anaconda distribution. I'm already sharing that Anaconda distribution. You'll see something called Anaconda Cloud, and there is another link which is giving Anaconda/Python. So click on this link. Are you guys following me, or you need a minute to open the browser and all?
1 minute, sorry.
Okay, is everyone here or?
Yes, Swami.
Okay.
Yes, Swami.
So once you are in this page, just click on this link, Python Anaconda Cloud. We'll get to this kind of a page. Oh, probably I'm in the wrong page, sorry. You go into the first link itself. It is a better one, I think. Are you here?
Yes.
Then in the top menu, you can see download Anaconda. Click on that. Are you in this page?
Yes.
Is everyone in this page or someone not in the page?
Yes, Swami. We are in.
Sorry? Okay. So once you're in this page, you can see below there is Windows, Mac OS and Linux. Select your OS. So if it is Windows, you click on Windows. Otherwise, click on Mac OS. Or if it is Linux, which I believe most probably it is not that case, you click on Linux. So mine is Mac OS, so I'm clicking on this. But if yours is Windows, you click on Windows. Then below, you can see two different versions, Python 2.7 and Python 3.6. Download Python 2.7. Do not click on 3.6, click on only 2.7. Is that okay? So if you click on this, the download should start immediately. I'm canceling it because I already downloaded, but for you have to download.
Swami, we don't need the 3.6 version for this.
Yeah, let's not go to 3.6. There is an incompatibility between 3.6 and 2.7.
Right. Yeah.
Okay. And I find 2.7 is much easier to work with actually.
Okay.
So download the 2.7 version. Are you all there? Are you downloading that?
I'm downloading something.
Yes, Swami. Downloading.
Yeah. So I have copied two instruction notes. One is Python for Mac OS installation and Python Anaconda installation for Windows. So these are some manuals that you can use. But anyway, I will show you how to do. But in case you did not follow properly, you can walk through these notes. It has all the screenshots and everything. So that should do for you.
So Sandeep, question. So why this version, Anaconda version of Python? If you go to the mirrors, can download 2.7 just by
Yeah,
itself.
actually, so Python 2.6, 2.7 and 3.6.
Yeah.
There is some incompatibility between the versions.
No, that fine. But I'm saying the skin for 2.7, the Anaconda skin that you're downloading from this site.
Mm-hmm.
Is there a specific reason, or because you can go to python.org and download the 2.7 also?
You can do anything, but the code that I have written for you is tested on 2.7. That is the reason.
Okay.
But there is a minor incompatibility. You can always go to 3.6, but I cannot guarantee all the code that I have written for you will work.
My question is not about 3.6 versus 2.7, but on 2.7 itself, on the python.org, you have 2.7 version also, the 64-bit.
Oh, you want to understand why Anaconda distribution?
Exactly.
So the Anaconda distribution itself will have a lot of packages for the data science.
Oh, okay. That explains it.
This is pre-packaged for data science, actually.
Got it. No, that answers my question.
Yeah. If you download the Python version and install all the packages required for data science, it's kind of difficult. Sometimes you have to compile yourself and install.
Okay.
This is very nice and easier. I have it always installed on my local machine. For that reason.
Yeah, I'll go ahead and uninstall my 2.7 original version and install this one.
No. Don't worry. If you already have a Python version installed, it doesn't matter. This will override that version.
Okay. Thanks, Sandeep.
Yeah. So, are you able to download right now? Or do you want to download today and shall we go for installation tomorrow? It depends on your internet speed.
Yeah, myself I did.
Sorry?
Myself I did. I downloaded.
Okay. Others, Vijaya, Zahir and Subbu.
It's downloading.
Yeah, should we wait now or should we do it tomorrow once you are downloaded?
It should be done in a minute, Sandeep. It's download.
Cool. Yeah. That's okay. Anyway, we have the manuals here. So I have already uploaded the manuals here. You have two manuals, one for Windows and one for Mac. I did not do for Linux because there are too many flavors. But if is everyone on Windows or which machine are you on?
Windows.
Okay.
I am Mac.
You're on Mac. Okay, cool. I like Mac. Mac. Okay. Let me know if everyone is done so that we can start.
Mine is completed. Sandeep, download.
Okay. Others, Zahir, are you complete?
I just started installing it, Sandeep.
Install we can do together. That's fine. I mean, if you can do, that's fine. It's not much, but we can do together.
No, you get started, Sandeep. I've downloaded it already.
Okay, cool. Yeah. And Vijaya and Abid.
Yeah, I downloaded it.
Yeah, I did download some.
Cool. Yeah. Thanks. So for installing, let me do one small thing. I have already some Anaconda installation. I just wanted to delete it so that we can do the installation together. Okay. I removed the installation. So let me go to my installation and walk you through. There may be some differences on Windows, but we'll see what are the differences. Generally, it should not be that much. So you'll see the installation like this. I mean the installer like this. Just double click on this, you'll get some pop-up like this, something like this. And I think Zahir, it will be little different for you. Let me know if it is different.
Yeah, that's fine, Sandeep.
Yeah.
I've worked on both machines, both flavors, and also
Right. It won't be very difficult to install. It's almost like next, and finally install.
Yeah.
But I just wanted to go through. Okay, you'll get some installer like this. Just click on continue. And then you'll get a readme. You don't have to read through all, but if you want, you can read. I would not suggest because it's too much. You can anyway continue, click on continue on this readme. Again, you'll have a license agreement. So if you continue, you are agreeing to the license agreement. So just continue on that and say you agree on the license. If you don't agree, then the installation will not proceed. So just agree on the license. So here you'll see either install on for all the users or for me only. It is up to you. Either you can select the install for all the users in this computer, but in my computer there is only one user, so that's why only this is highlighted for me. So you can just say continue. Are you all here?
Yeah, yes, Sandeep.
Okay. Now it will say how much space it will take. Ensure that there is enough space on your machine. It will take, for me, it is saying approximately 2 GB. It will be around the same for you as well. So click on install. So it will take a few minutes where it will go and install the Anaconda distribution. So the advantage of having Anaconda distribution again is there are too many data science packages. I'm going to describe like 4 or 5, but there are hundreds of packages actually. The 4 or 5 I'm going to describe are going to cover at least 80 to 90% of your data science regular work. But obviously I cannot teach 100% of everything. So it's the same with Python as well. So the rest of the 10%, you might have to install new packages and all those things when you are working with the data science, in data science. So in those cases, Anaconda distribution will help you to install easily all those other packages. So that is the reason why I generally go with Anaconda distribution, and it is one of the best packages in Python actually. So it's still saying 10 more minutes. I think we are already out of time, but let the installation proceed. And once the installation is complete for all of you, we can stop the discussion for now. Okay, it's still installing. It is saying 1 more minute, and now it is done. So is everyone done with the installation, or anyone left over with?
Still going on, Sandeep.
Okay, let's wait for a few more minutes. So the way I want to go forward is I want to teach a little on this Python every day, so that slowly you'll get some pickup on Python. At the same time, most of the time will be on the conceptual learning itself. But at the end of the day, just like the way we did today, we'll try to put some time for this installation work, running some Python code, some basic Python scripts and all, so that you'll get up and running on Python as well. That's how I'm planning. We'll see how that will go. So are you all done with the installation?
It's taking some time for me, so
Well, it's taking some more time, Sandeep.
Okay. Is it a few minutes or much more than that?
It's towards the tail end, Sandeep.
Okay. Is are others done? Vijay and Subbu, are you done?
No, it's still taking some time.
It's taking time, Sandeep, maybe 1 or 2 minutes.
Okay. So for those of you who are done, go to your terminal. In Windows, it will be your command prompt. In Linux, in Mac, it will be terminal. It's called terminal. If you cannot find it, in Mac, you can say command and space. You'll get a spotlight search and you can do terminal. You can search for terminal and then click enter. On Windows, you have to click on the start button. You'll say an option to search. Click on the search, type CMD and enter. You'll get a command prompt. And there you can do which Python. If you are getting a path which is in the path, if the path contains Anaconda, then your installation is perfect.
Compulsory that Anaconda 2 should come in the
Yes.
path.
Yes.
Mine is user local bin Python, it is coming.
Even after installing, or
Yes, after installation is over.
yeah. So probably your terminal is already open. Close the terminal or create a new terminal and try.
Okay. Yes, now it is coming. Anaconda 2.
Yeah, new terminal should come. Older terminal will not have that Python.
Yes,
Okay,
sir.
are others done?
Sandeep, on the CMD,
Mm-hmm.
I don't see which Python working.
Oh, which is not working? Huh?
I think
Long time. It's long time since I worked on Windows. Let me check back. I could not remember the command. But is your installation done?
yeah.
Okay. I don't know which alternative for which. I'm not sure. Okay, in Windows it is kind of much more complicated than what I thought. I think you have to open PowerShell and try this.
Okay.
You have to try where instead of which, it looks like. Can you try in the command prompt itself where Python?
It's showing me the old Python, Sandeep. Python 2.7, Python.exe. It's not showing the Anaconda version.
Okay, can you share your screen? I'll tell you how to do it then. I'll stop my sharing. By the way, is everyone done with the installation?
Yes, Sandeep, I am done.
Myself, I'm at the tail end.
Okay, then probably we'll wait for tomorrow. We'll fix the issues whatever we face tomorrow then. Because I think everyone is not done. And we are already overbooked by 10 minutes, 12 minutes.
Okay, Sandeep.
Sandeep. I'll try, I'll check.
Okay.
Okay.
People who are done with the installation, you can leave. People who want to, continue further and complete the installation, you can stay here. That is fine for me.
Sure.
Vijay, are you done with the installation?
Yes.
Okay, are you able to verify as well? Can you go to a new terminal and say which Python, and are you able to get this kind of a path?
Yes.
Okay, then you can leave, Vijay, if you are done with your installation.
Okay, see you tomorrow then. Bye.
Sure. Okay, bye. Abid, are you done? Is it your Windows machine for you as well?
Yeah, it's Windows machine for me, but I'm not sure why does it take so much time. It is still running fast, but
Okay. So Zahir, probably now you can share your screen. I'm copying my share.
Yeah, once again, I'm uninstalling the old Python. Sandeep. And Zoom is not letting me share the screen because there are other participants.
No, I already unshared, so you should be able to share. Yeah. Can you do where Python? Okay, where Python you did, right? Can you go to my computer properties You have to set an environment variable, it seems like. By the way, Zahir, if you are okay, you can do it now. But if you are, if you are feeling it is late,
No, it's fine.
tomorrow as well.
Computer management. Because I can see Anaconda. It's installed.
I cannot see that. Can you? I think, are you sharing everything?
No, I'm not. See here?
Yeah, you can see that. Can we go to your C program files?
Let me check now.
You can do that on the Explorer. Yeah, where Python? Okay.
Not working. After I uninstall the 2.7 old version.
That's fine. That's fine. We can fix it. Can you go to Explorer and browse through the C program files and Anaconda? C program files. Anaconda, is it there? I think it is in the program files 86. It's not here as well. Then it should be in the C directory itself. Can you see Anaconda here?
No, I don't see it.
Weird, it's not anywhere. Can you search here in the in all your directories? Should be somewhere here, I believe.
Yeah.
Yeah, C users. Oh no, this is different, right? This is your installer.
Yes, exe.
Interesting, it is not finding yet.
Let me search the. Something called Anaconda prompt. See the program.
Yeah, it is in the program data. Okay, I think, can you go, can you type where Python here? I think this is setting all the Python related things. Yeah, so probably you have to go through the prompt in Windows. You can also do it generically. Can you see the search? Is it able to search for the Anaconda?
So when I do the search, Sandeep, that's what it brings up the Anaconda command prompt. And
Can you browse program data?
yeah, absolutely.
Yeah. Anaconda 2. Yeah, this is the one, I think. No, this is only installing the DLLs.
Yeah.
C program data Anaconda 2. Okay. Can you do one more thing? In that prompt, type Jupyter Notebook. JUPYTER Notebook. It will take a few seconds. Okay, Windows is little weird, but it's working. So can you go to any browser of your choice and type localhost colon 8888. I think you're set. Can you go to any browser? Yeah. Yeah, you're set. So from here you can write any Python programs and run any Python programs from this prompt actually.
Which this prompt?
Sorry?
Or this prompt, right?
Sorry?
You were talking about this prompt, right?
Actually, from command prompt, if you type Jupyter Notebook, it will open this kind of a, it will create a server actually internal to your machine.
Okay.
And from this point, can you go to new?
I don't know what this is.
Sorry, Anaconda Navigator is for installing the Python packages.
Yeah.
You don't need for now. That is fine.
Okay.
All you need is the prompt. And in that prompt, you have to type this Jupyter Notebook and you'll get this kind of a browser window.
Okay.
And in this window, you can create, there is a new there, right? On the right top.
Yeah.
If you create Python 2 notebook, click on that. You can do any Python coding here itself.
Okay. Okay.
So that is the advantage of this Jupyter. Again, if you install, you can type, let's say, 2 plus 3, let's say, if you type and click, type shift enter.
Okay.
So it's a Python prompt actually. You can do any Python coding here.
Oh, okay. Okay. So basically, Jupyter Notebook is just an interface to the Python shell.
It's an interface, and you can do all your data science analysis within this notebook itself.
Oh, okay. And from here, just take it and pass it to the Python exe and execute it.
Yes, you can do anything from here.
Okay.
You can, once you create this notebook, for example, anyway, you got that, right? I'll show you how the notebook works. Can you unshare?
Sure.
Abid, are you able to install in the meantime? I was just focusing on Zahir. Zahir, you remember that you should go through the Anaconda prompt. For me, I don't have Anaconda prompt. I'm going through the terminal.
Yeah.
Okay.
Yep.
Okay. Abid, are you all set or?
Still it is taking time. What happened is like I installed Anaconda earlier and I uninstalled it and again I downloaded and again I started installing. So,
Okay. That is fine. Let it install. We'll see tomorrow.
When I install Anaconda earlier, I'm able to see that local browser colon 8888. Let me see.
So Zahir, are you able to see my screen? And Abid as well, both of you.
Yeah.
So here, if I type Jupyter Notebook, it will take a few seconds anyway. Yeah. Now I got this kind of a prompt. For me, it is opening automatically. Somehow it's not the same case in Windows, but that's okay. As long as you type in localhost colon 8888, it will work. And if you see, for example, we are talking about descriptive statistics right now. You can create a complete notes like this. See, if you see here, I'm giving some headings and all, which is using this hashes. So it has a complete markup, as well as you can run your code. So for example, if I run numpy, this one, it will import the numpy. It's running some, it's creating some array, and it's calculating some percentile.
Okay.
So all the things I can do here itself. In fact, if you want any graphical things, you can do it here itself. The graph will be displayed here itself.
Okay.
Okay, that's how you can do. I have some graphs as well to give you more intuition. It's a complete package. You can do anything here.
So is this something that you have to import, Sandeep, from yours, or do you just create?
I can just give this IPython notebook files, IP and by, I think. Is it correct? Yeah, IPynb, IPython notebook.
Oh.
If I share this book, you'll be able to run it. So for example, if you remember, we did a central limit theorem simulation, you remember? I can do that within this notebook itself now.
Oh. Okay.
So it's that easy. Just to give you a flavor of what we are going to do.
Okay. Right.
Okay.
Yeah.
Hope this helps. I think we are already overbooked by half an hour. It's very bad. Okay. I think for you it is done, right?
Yes. Sandeep.
Okay. Abid, are you done, or should we do it tomorrow?
I'm gonna complete it and I will notify you someday.
Okay, that's fine then. We'll do it tomorrow then.
Sure.
Okay.
Okay.
Okay then. Any other questions, Zahir and Abid?
No, good, Sandeep.
I'm good, Sunday.
Okay. I hope this is interesting for you.
Yes.
Yeah.
Okay then. Yeah. Thanks.
Thanks.
Thank
Bye.
Bye.